Okay, so this is another problem, brief exercise 14. Okay, and you can also check the solution, which is pretty clear. But I want to uh, discuss here by answering some students' question. Okay, again, we are given a problem. First, you should convert this problem to a equation or a formula, right? And the next is calculation is basically easy. Okay, you look up table and then use your calculator. You're done. You get the answer, right? So the first step, you should correctly translate the problem into a formula. So actually, see here, Amy want to create a fund today, and will enable her to withdraw 25,000 per year for 8 years. So there will be 8 withdrawals every year, amount 25,000, equal amount, right? And the withdrawal takes place. First one is in 5 years from today. Okay, so let's first draw a chart from 1, 2, 3, 4, 5. Okay, so this is today. She should prepare a fund here. And available for the first withdrawal here, 25K for the next 8 years. 6, 7, 8, 9, 10, 11, 12, right? So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 withdrawals, 25K. 8 25Ks. Yeah, keep in mind the first one happens just at 5. Now, it asks you what's amount fund here, right? And yeah, it looks like it is a problem of annuity, right? Same amount, same interval, and interest rate is same for each period. But there is no withdrawal here, right? So what we do is we just create a fake for withdrawals. Okay, I just use different colors. Here we just assume there are 25K for each period, 4, right? And keep in mind these 4 withdrawals are fake; they are not real. But when we do this, what do we have? Yeah, we have an ordinary annuity and 12 periods, right? So we can calculate the present value. Yeah, the present value of this ordinary annuity equals the payment multiply present value factor ordinary annuity is 12 periods, 8%. Okay, the payment is 25K. The factor we can calculate or you look up table. But we know this 12 period annuity, ordinary annuity, is including 4 fake payments, right? We should subtract them. And actually, if we start from 0 and till 4, this period, actually it is a 4 period, 4 payment ordinary annuity. And they are actually fake withdrawals, right? So if we calculate the present value of this fake ordinary annuity from the one we calculate, right, we can get the present value of all these at 0, right? So we create another present value. This represents the fake withdrawals. His payment is also 25K, but the thing is present value factor is different. The present value factor is 8%. Okay, so the amount, the fund Amy should deposit is PV subtract PV. So it's 25K multiply PV factor 12, 8% subtract PV factor for ordinary annuity, okay, 8%. Okay, so this is one method. Okay, we still have another method. So because the first withdrawal happens at 0.5, we don't need to create these fake payments. What we do is, if we consider 4 is 0, right? So this will be 4 will become the starting point of this annuity. Yeah, so it is 8 periods annuity, right? Yeah, we first calculate the present value at 4. Yeah, so it's 25K multiply present value factor 8 periods, 8%. Yeah, but we know this value represents value at time point 4, right? So we should calculate present value as 0. What we do is, yeah, we treated this amount here as a single sum problem by multiplying present value factor 4 periods for 8%. You should be clear in mind. This one you look up table 3. This one you look up table 1. Two different factors. Okay, this is ordinal annuity. This is a single sum. Okay, so this method is we find a starting point and discount all these cash flows to this point, treat it as ordinal annuity. Okay, and then treat the present value or value at 4 as a single sum, all the future value from point 0, right? Then we discount 4 periods to 0 by multiplying this single sum present value factor.